So we have this cubic and the tangent's been drawn. So what do we need to do? We need to find the equation of the tangent at x equals a. So I'm going to interactive calculation line, tan line, x equals a. And that gives me a y equals minus 3a squared x plus 2a cubed plus 1. Okay, in part B, find the x-coordinate of Q in terms of A. Well, that's going to be this. If I set that equal to 0 and solve for x, that will give me the x-coordinate. So that is x equals 2a on 3 plus 1 on 3xa squared. So find the coordinate P in terms of x. So that will be the intersection point of this cubic and this tangent line, and I should get two answers. I should get A and whatever P is. And I got A and minus 2A. That's minus 2A. Therefore, x equals minus 2a is that coordinate. Okay, let A be the function in terms of the total area of the shaded regions. Find A in terms of, okay, so the total area will equal the integral from minus 2a to 1 of y is the tangent minus f of x dx, then the integral from 1 to the x-intercept, which is this, 2a on 3 plus 1 on 3a squared, and that's of f of x dx. So it's going to equal, on my calculator, I'm going to have the integral from minus 2a to 1 of the straight line, which is this one, minus, and I might put in a bracket, and that's the cubic dx. And then the last little bit is from 1 to this, so the integral of the straight line from 1 to the intercept, which is this. So I'm going to copy that, paste it with respect to x. Okay, and then I've got that answer plus this answer, and simplify the answer, and there is my area, and it's going to be 20a to the 4 on top of 3 plus 2a on 3 plus 1 on 6a squared minus 3 on 4. If you're interested, you need combined. That's for combine. It's also equal to 80a to the 6 plus 8a cubed minus 9a squared plus 2 on 12a squared. Find the value of a for which a is a minimum. So if I take that and take the derivative of it with respect to a, set it equal to 0, and solve for a. So that value of a is going to be a minimum. So dA equals 0, solve for a. That's my method. And a equals 1 on 10 to the 1/3. Okay. Consider the regions bound by the inverse, the tangent to the graph at B, where B goes between 0 and 1. So find the regions bound by the graph. Find the value of B for which this total region is. This is the same as this region up here, except it's the inverse. So this area is the same as this area up here, because if I've got between function f and its tangent at this point between 0 and 1, and I'm minimizing this area, then if I consider the inverse of the function, the tangent of it, and where is it going to be a minimum, it's going to be the same values. So if I consider the y value of sorry, 1 minus x cubed given x equals 1 on 10 to the power of 1/3, that's going to give you that b value. So I'm going to have 1 minus x to the power of 3, 3 given x equals this. Then b is going to equal 9/10. And find the value of the acute angle between the tangent of the graph of f and the tangent of the graph at x equals 1. Okay, so I've got this graph. If I find its inverse, so if I take that, replace that with a y, make it equal x, and solve for y. So that's the inverse. So if I look at these two curves, I'm interested in at x equals 1, the angle between them. Now, the red one, that angle is vertical at x equals 1. So I've got 1, which gives me a vertical angle of 90 degrees, and the other one that looks like this. So it's going to be the inverse tan of -3 minus pi on 2, or pi on 2 minus inverse tan of 3. Either of those would give me this angle in here.